Hey everybody, it's Mr. Mott. What we're going to do is a demonstration that's going to show you that the law of conservation of matter or law of conservation of mass works in real life. Oftentimes it's really hard to prove because of gases that are involved, and so we're going to hopefully kind of demonstrate that today. I've got a piece of steel wool, which I'm going to take this, I'm going to soak it in some vinegar. It's going to accelerate the reaction with oxygen. I'm going to stuff this into an Erlenmeyer flask and then put a balloon on top, which is going to conserve any gases that are used up or created in this process. All right, here's our steel wool that's soaked in vinegar. I'm going to go ahead and stuff this into our Erlenmeyer flask and then cover it up, and then what I'll do is I'll record the rest of the video in a time lapse so it goes a bit quicker. You can see the reaction taking place. Pay close attention to what happens with the balloon. All right. All right, everybody, this is the next morning, actually, of the Law of Conservation of Mass demo here. And what you can see is that the mass has pretty much stayed the same. The balance is fluctuating a little bit with the air currents in the room and so forth. What we can see, hopefully, in here is that our steel wool looks a lot more brown because it looks like rust. And so the iron in the steel wool is reacting with the oxygen that was in the flask, all the gases, the oxygen that was used up, that was what you saw when the balloon had kind of gotten pulled in, because some of that volume of gas was used up there. Obviously, this is not a perfect system, so there might have been some gases that could have escaped and so on, but in the time-lapse video you did see that the gases were pulled in. Depending on the size of the flask, depending on how much steel wool you can get, sometimes what happens in this demo is that the balloon will actually sort of get kind of inverted, and it'll go all the way sort of on the inside of the flask. But hopefully that helps you understand sort of a little bit about law of conservation of matter. Also, how tricky it is to, in practice, keep track of everything, because a lot of times you're dealing with gases being used up or gases being produced and that sort of thing. Thanks for watching.